What we have done is we have defined work as force F dot D or F dot S. So, if work is equal to F dot S, we need to understand how to do this dot product. Understand that scalars can be vectors could be multiplied in two ways. Okay, vectors could be multiplied in two ways. One is called a scalar multiplication or the dot product, and one is called the vector multiplication or the cross product. What we are going to learn today is we are going to understand a little bit about cross product. So, the definition of cross product, suppose A dot B, A is a vector quantity, B is a vector quantity. A dot B is defined as mod A mod B cos theta. Because it is a scalar, there is nothing here. So, A dot B is defined as mod A mod B cos theta. Geometrically, if you want to understand what it means, is this: suppose there is a vector like this, there is another vector like this, this is A vector and this is B vector, then mod B is nothing but the size of this vector, mod B cos theta is nothing but the projection of B vector on A vector. So, A vector dot B vector is equal to magnitude of A vector into projection of B vector on A vector. That means, if you throw light this way, the length of the shadow will be equal to this projection, this amount, that is going to be equal to B cos theta. So, A dot B is defined as mod A mod B cos theta. I can look at it as mod A into projection of B on A, or I can also look at it as mod B into projection of A vector on B vector. Either one of them I can look at it. Okay. So, this is how you define A dot B, which means that if I have I cap dot I cap, it will become equal to 1 into cos 0 is 1. So, I cap dot I cap is equal to 1. I cap dot j cap will be 1 into cos 90, and cos 90 is 0. So, I cap dot j cap will be 0. Similarly, j cap dot j cap will be equal to 1. Similarly, k cap dot k cap will be equal to 1. So, j cap dot j cap, k cap dot k cap, these will be equal to 1. I cap dot I cap will also be equal to 1. Any other things, when you are multiplying, it will give you a 0 vector. Okay. So, if we want to understand this better, suppose I have a vector x1 I cap plus x2 j cap plus x3 k cap being multiplied with another vector, let us say y1 I cap plus y2 j cap plus y3 k cap, and suppose we have to do the find out the dot product, then this one will become equal to x1 y1 plus x2 y2 plus x3 y3. What I have done is I have multiplied this with this, understanding that j dot I dot j will give you 0, I dot k will be 0. Similarly, I multiplied these two, understanding that x1 x2 y2 will become equal to only this will exist, the others x2 into y1, x2 into y3 will both give 0 vectors. Similarly, I am multiplying only this with this, so that I understanding that the others will be 0. So, if this is A vector and this is B vector, then this is equal to A vector dot B vector. Okay. So, this is how you find out the dot product of vectors. So, what you need to understand is that the dot product of vectors is nothing but the projection, the product of magnitude of one vector with the projection of the other vector on this vector. Okay. So, just to give you a small example, suppose I have 3 I cap plus 4 j cap minus 7 k cap, and the displacement vector, this is the force vector, and the displacement vector S vector is equal to 2 I cap minus 3 j cap plus 1 k cap. Okay. Then the work done by this force is equal to F dot S, and that will become equal to 3 into 2 6 minus 4 into 3 12 minus 7. So, that will become equal to minus 19 minus 13. So, it will become minus 13 joules, provided this was in newtons, this was in meters. Remember, work done is negative. Work done is negative, which means that work is done on the system. Work is done on the system. and work done, if work done is positive, it is work is done by the force. So here work is not done by this force, work is done on this body, okay. And if work done is positive, it means that the force is doing work, the work is done by the force, okay. So there are two things when we need to understand this work. You can look at it from the system perspective, you can look at it from the force perspective. So there is a small error in this understanding, so I will just clarify that error. If suppose this is a system and work done by this system, work done by this system is positive, it means that the system has pushed something, or the system has undergone an expansion, okay. If work is done on the system, then it means that there is a system, there is an external force which is acting on the system, and that external force has resulted in some kind of a decrease in volume, okay. Now if a force is done, if there is a force and then this force and then this has brought about some displacement, if work done is negative, it means that work is not done by the force does not do any work. Basically there is something else which is acting on that, which is doing work, or the force and displacement are not along the same direction, but they are in opposite direction. Say for example, if you take friction, so suppose there is a force here, this body is moving, frictional force will be opposing this body moves in this direction. So work done by friction is negative. Why? Because cos theta is 180. If cos theta is 180, cos 180 will become equal to -1. So the work done is negative. So if this force, if there is a force here and there is a displacement and the work done is negative, it just means that this force causes a reduction in energy. Causes a reduction in energy. Okay, and then if the work done by a force is positive, it means that it causes an increase in energy. Okay, we need to understand this a little better. Subsequent videos will explain this.